I've been living in France for the last 30 years. I think at 9 years of age, anything French seemed to fascinate me. And my great-grandmother happened to have been brought up, even though she was Irish, in Paris. And I think that obviously influenced me. You can see that I had the curly hair as a child. The first apartment was up at the Trocadero, overlooking the Eiffel Tower. So you knew where you were when you came out the door. I was painting, I was making a film. My children were happy and they'd done very well at university. Everything was working out like a great dream. Well, I usually have loads of energy, and suddenly I had none. I thought I was just jet-lagged, but then I realized it was more than that. So I went to my local doctor in the south of France, where I was at the time, and asked for a scan. And I had a scan the next morning, and that evening I was in the clinic seeing the anaesthetist. I sort of went numb. My brain went numb. I'm not sure where we came up. Did we come up here? And feeling it was like walking to the moon or somewhere, but it's a tiny little. Well, I think when you're very ill like that and you're not, there's something in your subconscious that is telling you something isn't right. So I was sort of prepared for some kind of a shock, but I wasn't prepared to be told that I had to have chemotherapy. And I don't think people realize, how lucky we all are. That
from a gastric standpoint, you feel okay?
But as soon as I heard that word, I just instantly accepted that that's what I had to do. And I looked straight in the eye of the doctor and said, "Are you going to save me?" And he said, "Yes."
This is very good. I remember when you called me, Dr. Grimaldi, I have to meet you very quickly. Was it a shock for you when I spoke of chemotherapy?
Yes.
Did you understand that cancer
Yes.
was an hypothesis, a very serious hypothesis?
Yes, I
That's what I
did.
had in mind.
But because my daughter was with me, I didn't want her to be shocked as well. I suppose one part of my brain was numb and the other part was saying, "You've got to fight this, you're not going to let anyone down." I didn't want to let my family down. I didn't want anyone to think, "Oh dear, what are we going to do? She's going to die." When I was with the doctors, I felt a great sense of trust. My oncologist, Dr. Gérard Lesbat, just had kindness just emanating from his whole face and head. Dr. Lesbat told me about the great French pioneer of immunotherapy, Georges Maté. And I realized I had met him, and I thought I should find out more about what he had done and who the other pioneers were. Also to reflect on my case, to help others facing this shocking disease. It's a real walk on the wild side. For them, the doctors, and for me.
Mate was one of those, and there were three others, who were James Holland, Emil Freyreich, and Emil Frey. And those four persons, I think that they were really the soul of the chemotherapy, of the early years of the chemotherapy. So they really influenced me.
Mate, Holland, Freyreich, and Frey.
Beautiful. I think it increases the value of your house. Who's this handsome young guy? You get younger every day.
Yeah.
Younger and handsomer.
Getting a little gray.
You look terrific.
Jim, how are you?
I'm good. Great to see you.
Good to see you, Jim.
Welcome to Westchester. How you doing?
I had a stroke.
I heard, but you're doing better than that. You're not in trouble from it. I don't see any
Well,
trouble.
I can't walk. That's a problem.
Okay, well, we'll with you.
You weren't walking much before your stroke either. You know, I tried very hard to go to Harvard, but Frey wouldn't hire me.
Harvard has its own criteria and its own
criteria.
committees, and they turned me down. So that's
Turned you down too.
you're sure.
Frey knows. I think you got turned down, and then he figured he'd take the second best.
I was born humble, but it wore off.
Yeah.
You heard about this guy, the Miracle Man. He's had 2 bypasses. How many angioplasties?
Can't count.
Boss. You know, we all called him the boss at
Well,
MD
the boss to
Anderson.
his face.
Always. I'll tell you, when I see him, I really feel better. It's therapy for me to see Tom Frey. He's a terrific guy.
Cancer chemotherapy started with Paul Ehrlich back in about 1898. And so it was, in fact, his genius, and he was a genius, that began the concept that drugs could affect cancer. When I started, cancer was a disease you didn't discuss. It was a shame. It was really an outrage that people got cancer. It must have been something they'd done wrong. They were being punished.
All the facilities for treating patients were available. We elected to focus our resources and our brains on the cancer problem in children with acute lymphocytic leukemia.
The one who hired me, Gordon Zubrod, said, "Freyreich, what do you do?" I said, "I'm a hematologist, sir. Just completed my training." He thought a minute, he said, "Why don't you cure leukemia?"
We were lucky. We were there at a time when other good men, Zubrod, Law, Birchnell, influenced us, and they helped us. And we're not unique. We're just beneficiaries of societal progress.
Well, we were inspired from multiple sources. Perhaps the most important was the clinical side, seeing the patients, realizing that you could do nothing to change the ultimate outcome, which was fatality.
The road to curing cancer is through leukemia. Because leukemia is something we understand. It's accessible. We know what the problem is. We know where the disease is. We can sample the blood and bone marrow every day. We can grow the cells in the laboratory. We can treat them in vitro. If we can cure leukemia, we'll cure cancer. These children bled to death. And when we gave them the chemotherapy, it aggravated the situation. They bled more. 85% of the children bled to death within 8 weeks of diagnosis. This was the natural history of the disease. And when they were sick and lying in bed and sleeping and bleeding from the gums, they would go, they'd spray blood over the ceiling, on the drapes, on the walls. Everyone on the staff had blood on their coats. The nurses were covered with blood. They bled in their urine and the stool out of their mouth and their skin.
the contribution that Fry and Freireich and Zubrod, who was our leader, and I made were that we found that a single institution couldn't realistically provide the kind of critical scientific evidence that people demand today.
So I noticed that all the children had no platelets in their blood. And I knew from the literature the platelets were important in clotting. So I drew blood on all these bleeding children, and I took the platelets out of my blood, separated them in the lab, put them into blood, and everything seemed to go back to normal.
You used your own blood?
My own platelets. So I said, what we need to do is replace the platelets. That'll stop hemorrhage. But no. See, they'd done studies in animals where you could radiate them and they get no platelets. They don't bleed. You can remove platelets by pheresis. That is, take a blood out, take the platelets out, put the blood back. And you can make them have no platelets and they don't bleed. Dogs, mice, rats, they don't bleed. So obviously it's not the platelets. There's something else. I mean, this is 1955. We would give these children 1 unit of freshly collected blood or 1 unit of bank blood that was more than 10 days old, which had no platelets. And we'd see if it affected hemorrhage. And everybody knew it wouldn't, except me. So we did it. And when we did that, bleeding was eliminated. We did a study 5 years later and showed that as a cause of bleeding, it went from 80% to 10% in a year. So we'd conquered bleeding. Now, children didn't die of hemorrhage. They died of infection. We looked at the charts of all the children and compared their white counts to whether they had an infection. And we showed that as soon as their white counts got below 500 per microliter, they all got infection. Could we replace white cells the way we did platelets? So I was sitting in my lab one day doing with all these tubes and test tubes and centrifuge, and a guy walked into my office, a meek little man, short, meek, quiet guy, said, "Dr. Freireich?" "Yes." "Dr. Block sent me up to see you." I said, "Yes, what about?" "Well, my son has chronic leukemia, and I asked Dr. Block, who's his doctor, a friend of mine, what I could do to help." He said, "There's a crazy guy up on the 12th floor who wants to build a machine to collect white cells. Why don't you go talk to him?" So here I am. So I sat down with Mr. Judson, George Judson, and we wrote down what I want. I want an instrument that will process blood at 500 ml every 2 minutes. I want it to be able to collect supernatant, precipitate, and buffycoat on a continuous basis in a totally closed system, vein to vein. How about it? I said, okay. So Judson and I went to work in the lab with this blood, and we built the machine, and we reported in 1965, and we hold the patent on the continuous flow closed system blood cell separator, which is used in every blood bank around the world. And we succeeded in getting white cells. Now, it's one thing to cure infection and one thing to cure hemorrhage, but the fact is that they were all dying of leukemia.
And the key goal had to be the cure. Was it possible to change that picture?
Chemotherapy began with the nitrogen mustards and with the folic acid antagonists in the late 40s, and I was privileged to treat a child with aminopterin. Since then, there have been many derivatives of that same chemical family and of many other chemical families that are of great interest.
The word cure was critical. And prior to 1957 or 58, we didn't use the word cure ever. in dealing with cancer patients. The first studies we did were comparing the two agents that were known to be effective in childhood leukemia. And particularly, we found that when the two were given together, the response rate was greater than with either one alone.
That initial combination of the Cancer Institute, Roswell Park, and I had recruited the Children's Hospital of Buffalo. The three of us did the first study in combined chemotherapy of children with acute leukemia, and that got published in Blood and was the first paper of a combination chemotherapy group activity in the United States.
So the next step on the road to cure occurred almost concurrently. Eli Lilly had a program to find anti-diabetic drugs, and they were pursuing folklores. And one of the folklores was the periwinkle plant had some alkaloids that could affect diabetes. So my job was to screen these alkaloids in animals. And I noticed in the mice that their blood counts were low. So I said, wow, it didn't do any good for diabetes, but their blood counts were low. Maybe it's good for leukemia. So he got a leukemia called P388. He studied this drug, and wow, it knocked him for a loop. So I said, listen, guys, I want to give all four drugs at the same time. I knew the doses of 6-MP and methotrexate. I knew that I could add prednisone full dose. I knew we could add vincristine full dose. How do you think that was received? The hierarchy at the Cancer Institute wanted to have me institutionalized. They thought I was crazy. So Fry came back and he said, well, this drug is not active in L1210. So Dr. Zubrod said, no. I said, look, Dr. Zubrod, I've got 10 kids dying on the ward. What's the difference? We know it's safe. We know the dose. How about it? So he thought about it overnight and he said, okay. We gave vincristine. It was magic. Of the first 10 children we treated, 5 or 6 went into remission, boom, like that. We gave the first multi-agent combination chemotherapy to children we did the first eponym because you couldn't write vincristine, amythyr, mecaprimir on the charts. We called it VAMP. And VAMP revolutionized chemotherapy in the world.
By 1960, looking back at the leukemia studies, it was clear that some patients were living beyond any expectation of their biology. And we began to think that some of these patients were cured. Now this was as much as 10 years after the initial introduction. The reason is that if the patient goes into remission and lasts for a period of time, you don't know whether the patient is going to relapse, let's say, 10 years out or what have you. Finally, we had enough experience to say that the risk of relapse out beyond, say, 10 or 15 years is essentially nil. So we cautiously began to think cure.
The challenge was enormous. Fear is something that goes along primarily with the unknown.
The real heroes of cancer research are the patients who volunteer for research treatment particularly, because they take the risk. And the doctor facilitates that, being positive, hopefully. The treatment will not only prolong life, but perhaps produce cures. The one thing you have to leave with the patients always, however well they do medically, is hope.
I really believed that I wasn't going to die. I did not want to die. I don't think anybody really wants to die. But I strongly believed that I would survive because I had so many things that I still want to do. I wasn't ready to say goodbye to everybody forever. My daughter was with me, so I didn't have to tell her, but then I had the ordeal of breaking the news to my son.
Sorry. Okay. Sorry, that was the worst bit.
No, I understand.
Sorry, I didn't think I'd have to remember
Yes.
those things.
I don't know how much you knew at the time, but we knew that the surgeon came out and told Christian the full story, that you had ovarian stage 4, that it had spread up the peritoneum, that, you know, you were really not operable at all. So we were sitting around the bed with you recovering silently. And then Dr. Lesbat walks in.
You are marvelous.
With this huge, big, smiley face. So are you.
Ah, mais il y a un film. Bonjour.
This is my...
Voilà Germaine. Merci Germaine d'être là. Bravo.
Walks straight up to you and goes, "How are you?" And you're sort of recovering, kind of. He said, "We're going to get you better." And we all really believed him. There wasn't any doubt in that moment that he wasn't, and it was an extraordinary moment. It was slightly like meeting God.
Yeah. He brought champagne in for me for the first time I had chemo. Do you remember that? It was all explained to me about losing my hair. My sort of trademark was my masses of curly hair, so everybody was more afraid about the whole thing than I was. It didn't really worry me. I was fascinated about what it would be like to suddenly look like Sinead O'Connor. That everybody thought would suit me because it looked like my hair.
Yes, but they were not
a different
very-
colour.
Oh, yeah.
But then after 2 days, even though I was very sick, I realised this is more for Halloween. Trying on wigs was fascinating. I can become someone else. The cancer was going very, very quickly, and I became really helpless. I felt I'd lost the plot, actually. But I was trying, for the sake of my children, not to be too upset. But I had nowhere to hide, body or soul. I was just crying out when in need or in pain, and waiting for somebody to take me in their arms to quench the anguish. I couldn't listen to music anymore. It made me cry. So I had to lie and listen to the birds. I dream in colour, actually, but suddenly I was having daydreams in brilliant colours. And I felt my brain had left my head and was staring back at me from outside the window. It was terrifying. When you're on chemotherapy, you're obviously not functioning as you normally would function. And I was told right early on that no major decisions should be made while on chemotherapy. But one day I was feeling so bad that I told my boyfriend to leave. And he did. And then I cried for days. Well, I knew there were lots of people in the house and friends coming to see me, but they were only allowed to see me for 15 minutes. And they weren't allowed to kiss or hug me because my immune system was way down.
We couldn't give you any indication that it wasn't going to be okay. And that was a very strong force with my brother, Christian, who came over and was just very pragmatic about setting up a system of rotation so that you had the support that you needed around you. And everybody had this sense of maintaining positivity around you at all times. And I think that was hard sometimes, having to pretend.
Yeah, I'm sure it
that
was.
we were all okay.
I was suddenly like a baby, helpless baby, and I couldn't do anything for myself. And I had to, it was very hard for me because I've never really had to ask people for help before. Look, it's probably easier for everybody if I just go, if I just die. And then I think, no, I'm not going to die. I'm just not going to die. And Vani, who's a doctor, she would, I remember asking her, is this how you die? I was lying in bed having the chemo pumped into me, and I suddenly couldn't see and I couldn't speak. And then I had this huge electric shock that just pounded right across my chest. And I thought, okay, I'm dying, but I couldn't tell anyone. My sister was crying and screaming, and then I heard her shouting. Then there was nothing. And then I was coming back to life, and I could see in black and white, actually, at first. And I could see my oncologist at the end of the bed, and he was saying, the trouble with you is that you're too healthy. Your body's made antibodies to the chemotherapy. I'd had an anaphylactic shock. My father was a surgeon, and I keep remembering he had a big old Ford V8, and he loved cars and he loved driving fast. And in this car, a voice came on when you went over 70 miles an hour. Okay, you're on your own now, buddy. I kept remembering this. Okay, you're on your own now, buddy.
The problem with cancer is that it's just a little bit different from regulation of normal growth. Cells have to be growing, and they have to grow up, and then they have to die. And the problem with the cancer cell is it's like wayward children. They keep on growing up, but they don't really grow all the way. And they don't know boundaries, so that they don't tend to stay in the same place, and they move from place to place. And I think we've had an unnatural fear of the cancer cell over time. We thought it was like Pac-Man that was just consuming the patient. But in fact, we now realize that they have some limited obeying of rules. They have a script that they have to follow, and if we can understand the script and we understand exactly what the message is, we can interrupt that message.
The causes of cancer are multiple. It's not a single disease. There are many kinds of cancer for each organ, and the fundamental abnormality is that the proteins in these cells behave differently. That may be because the DNA in these cells behaves differently, which may be because it's mutated, possibly by radiation or cosmic rays or chemicals.
Well, I was 3 months into chemotherapy when I had to get to Budapest for Nico's wedding. If I hadn't been so sick, I would have had a great laugh about the Monty Python element of getting there in a wheelchair and through Munich and arriving in this big hotel with all the people, and I couldn't walk for the first few days. But then, miraculously, all the drugs that the doctors gave me to prop me up started kicking in, and I was able to actually walk out of the church. One of my friends had said that I should tape the wig to my bald head and then pin the hat to the wig in case it was windy. And when I came out of the church, it really was windy, and luckily my wig and hat didn't fly off. The joy of my daughter being married, and that I could actually make it, and to see her so happy, that's what kept me going. Well, after a year, I was cured and getting back to my normal life. Yeah, it was great feeling that I hadn't lost what I had been doing before. It hadn't all disappeared. One of my checkups, and I, wasn't scared anymore. So far, so good.
Malignant tumors can, in fact, metastasize. They can invade lymphatic or capillary blood vessels, travel in the circulation, and go then to a distant site and go into another tissue. They can set up a metastasis in a remote place, which constitutes a second type cancer. And this is a very difficult situation and leads to most of the fatality that's associated with cancer.
In France, the patient is given the results, and I didn't bother looking at the results until I was waiting to see my surgeon. And then I looked at the results and totally freaked out. I felt that I'd been let down by the world, by the doctors, by everything. So I felt angry, actually. I was angry. I was very angry that this was happening. That it was like I'd been given the prize, but it had been taken away. We thought that I was in the clear. It happened to be with Dr. Mazagal when the result came.
He's a very good surgeon, yeah.
So he said, and I was very upset because I thought I was cured, but he said, don't worry. Actually, Dr. Lesbat was so upset. He was crying. And I said to him, don't worry. You saved me once, so you save me again. No problem.
This is very important.
Not a bird to be heard as I grabbed things to take to the clinic, wondering if this was my last journey. I had 6 more months of chemotherapy and more surgery. I was standing on the edge of a cliff. I was absolutely terrified. I didn't know how to tell my children. I felt such a burden and didn't want anyone to know. I only wanted to be with my doctors.
Anybody seeing patients today has a sense of urgency to try to help the person that's sitting in front of you right now. And we are blessed by having many new anti-cancer agents. Our goal of having so many in clinical trials is to have ones that are going to fit a particular patient.
It's a question of perfection of the methods that we have already and perhaps development of new methods.
We are using robotic technology mostly for prostate cancer. certainly for bladder cancer. We're also moving toward the kidney cancer through this robotic technology, making it less invasive by, if the target lesion is a walnut organ and it's a small target, you don't need to make a big incision to remove a small organ. So perhaps there were better ways to remove this. We did the first 11 robotic cases in France. And it's pretty amazing to see how this has revolutionized the field of surgery. When you put the science and the experience along with the technology all in one room, that's the kind of magic that the patients are looking for. And I think the new generation of surgeons are not just going to take these organs out and tell the patient, move on. That's not good enough. You want to make sure you get the trifecta, cure them, give them the sexual function that they're looking for, as well as the urinary control. And we're capable of doing that. And over 95% of the patients are cured and have excellent quality of life.
With advances in understanding the biology of cancer, there came the possibility to try to treat cancers with drugs that specifically target the cancer cells and don't affect the normal cells. And ultimately, our goal is to cure cancer without chemotherapy.
George Mattei had a dream before me.
Yes.
And he have the same dream. And when the first time we have it was 10 years ago, 5 or 10 years ago, it's not so long. We have the first target therapy. We have this first target therapy. We said, my dream is here.
From his experimental background, he created an option which was immunotherapy. He used several compounds to do that immunotherapy that work in the animals.
George Mattei had come and worked at Memorial Sloan Kettering Cancer Center, but I got to know him because we were both interested in leukemia.
Well, I was going to Rome from Paris, and the flight was delayed. And this older guy starts talking to me. I had no idea that he was this great pioneer of immunotherapy, bone marrow transplants, and chemotherapy.
Mattei was the first person who demonstrated a stable chimera after bone marrow transplantation.
He was the pioneer of the concept of immunotherapy in acute leukemia, and did some very remarkable work in classifying leukemias and in immunizing children with leukemia in a way that others in the United States were not doing at the time.
George was a man ahead of his time, so to speak, and he was always a pleasure to have around and a stimulus for doing new things and interpreting things in different ways.
So in the 80s, we started seeing the birth of the monoclonal antibodies and some of the targeted therapies, and these really took off in the 1990s as we started gaining more momentum about understanding what triggers certain forms of cancer, in particular leukemias, and how we can target them with some of the new drugs.
Today, we can analyze the genetic material of these cells and this material that is shed into the circulation. And we can indeed be sure that this is tumor material, because if we analyze the genetic material of the tumor and then what is in the blood, we find exactly the same mutations. So we know that this is coming from the tumor.
We reported a couple of weeks ago in the New England Journal of Medicine a very targeted treatment for patients with a bad tumor that erodes into the skull and other areas called basal cell carcinoma. And there's an oral treatment. It targets a specific mutation, and it just takes out the tumor. So the targets are better, the science is better in finding them, and we are finding agents to hit those targets. That's the good news.
So the tumor sends signals to the immune system, and the immune system doesn't work. And we now have drugs that can counteract these signals so that the immune system starts to work again.
Potential mechanisms of augmenting the body's own defenses are very real. There are a host of things that have been discovered in the recent decades that represent secretory products of different cells that influence the immune response. And the immunity against cancer that we all have with natural killer cells and T cells and macrophages potentially can be harnessed so that indeed it would be a characteristic if we discovered something that had gone wrong by some unique blood test and then could stimulate the immune system. In fact, the immune system might be able to find and eradicate such tissues.
I couldn't stop thinking about my father most of the time that I was having chemotherapy and being treated, and particularly when I was having surgery. I wished every day that he was still here. And I couldn't help thinking about all the great times we had sailing and how he'd say, "Stack out, and we're sailing up to the wind now." You know, he was always determined to win the race. You know, I was thinking, here I go again. I'm like one of the Simpsons, head shaved and radioactive for 48 hours.
The biggest problem that the Western world has in terms of curing cancer is regulation.
The time it takes to develop a new drug, to demonstrate that it can have a big impact on patients, has become very long today because of a lot of bureaucracy linked to clinical trials. And we have to do something about that.
We have to be risk averse. We're not allowed to take any risk. But the risk of cancer, particularly widespread cancer, the greatest risk is the cancer. And the failure is if we don't stop that.
It takes 15 years from an idea until it becomes commercially available. In the United States alone, 600,000 people die every year of cancer. 600,000. So in 15 years, that's 9 million people die, while the FDA is protecting them. I mean, it's insane. They're protecting them from nothing.
The challenge is now is doing things in a timely manner. We know some of the answers. They're perceptive, they're right there, but the clinical trials very often are hung up on in a maze of bureaucratic problems. Is no one at fault? It's just a number of people involved in the process.
The tragedy is that all this regulation was designed to prevent the thalidomide disaster. And it has nothing to do with cancer.
We always hear the motto that for a doctor, first do no harm is the key issue. I think in cancer, this motto doesn't apply, and it slows us down, because the worst thing that could happen to a patient with cancer is the progression of their cancer and dying from that cancer.
It has nothing to do with cancer. Patients are going to die in 3 months. People with cancer are prepared to take risk for potential benefit. They have no hope. Their only hope is progress. So what the FDA does is protect people from progress. They're killing people.
Standing by and watching and doing no harm, in fact, is the worst harm that we can do to the patient, because the cancer is going to kill them.
90% of the money we need to develop a cancer drug is wasted on the regulation thing. We spend all our money killing dogs and cats and monkeys and rats and cows and elephants and kangaroo, and none of it has anything to do with it. It doesn't help anybody. The money is available.
The number of people that suffer very serious side effects from investigations are actually very few.
There has been a breakthrough in England. They are now transferring the regulatory responsibility to the cancer centers and funding them. And that's what needs to be done.
Nothing is so unphilosophical as to say that because it hasn't been done, that his cure hasn't been achieved, it can't be done.
The ideas are there, the opportunity is there, the science is there, the biology is known, we've got the genes, we've got the molecular, we've got the targets.
Well, I want to make sure that I say to people that today cancer in many cases is something that is treatable and is something that is curable. In many cancers that people are very much afraid of, say breast cancer, for example, we cure the vast majority of patients with this disease today with the treatments that we have today.
I think people have to now be more proactive, and it's much easier because there are more tests available. I think people should not be afraid to go to their doctor and ask for a scan, ask for a blood test. If they're not sure, if something doesn't feel right, don't be afraid, just go. They have great treatments now. It's not the doctor's fault that you've been diagnosed too late. He will do his best to save you. If you've been diagnosed too late, it means you didn't go to the doctor in time. So this is really important for people to understand. It's your responsibility, your life.
Every disease is unique because of the person attached to it. One of the great pleasures of dealing with chronic lymphocytic leukemia, or CLL, is that you actually get to know the patients very well because it goes over a long period of time. So that it's the psychology of meeting them, trying to make them unafraid of the diagnosis.
I would say that 90% is the power of mind and your outlook at world and whether you want to be alive and fight the fight. There's no doctor or surgeon that can fight for you.
Emotional aspects of cancer are not different from emotional aspects of many other diseases. Most people don't want to die. Everybody wants to go to heaven, but very few people want to take the necessary step to get there.
In a way, it was harder the second time because I had to find the faith again in the whole process and the doctors and the drugs. But I got through, and, you know, having the last PET scan that showed all clear was just amazing. In a way, it was like, you know, I'd won the marathon and the Oscars and everything all rolled into one. According to the anaesthetist.
Yeah.
And I said, "You're kidding me."
Yeah, you are.
My drug dealer.
Comment ça va?
Ça va, très bien. How are
Alors?
you?
Fine, and you?
Very fine, thank you. And all the better to see seeing you.
Yeah, marvelous. You are marvelous.
Well, you look fantastic. I love
but we like our job, and it was so fantastic job. And Really, thank you. I know it's very hard for you. Let's remember so many things. Okay. Sorry. No, it's natural. We are human people. We are human. It's normal. It's necessary.
So stay in the moment, stay young, stay healthy, because you're an incredible woman, and I'm incredibly lucky to have you as my mum.
Wow.
See your face. Well, you smile. Sleepy girl. I had to get my confidence back. I think most people that have been through chemotherapy and all that goes with it, you lose your confidence, and that was hard for me. So that it was hard, but I'm glad I did it. Your whole life changes, and you change a lot.
And what about your sexual life during cancer?
Well, actually, I was amazed. It wasn't over. I'm dreading the results of the mutated gene test. I told my sister, who's the doctor, that I was having this, and she said, well, thank you for doing this for the family. At the Marie Curie Institute, they were so kind, telling me not to feel guilty if I do have the mutated gene.
We know some genes that are involved in carcinogenesis for breast cancer and for ovarian cancer. And those genes can be transmitted to the children, and it's a direct transmission. So if you carry the gene, you have a major risk of breast and ovarian cancer, and the chance you have to transmit the gene to your daughter is 50%.
I don't have the hereditary mutated gene, which can cause ovarian and breast cancer. What a relief for my daughter, my sisters, and my little granddaughter.
Having the mutation, unfortunately, is a high risk of developing the disease, but it's an opportunity to have a benefit from new treatments.
You were really helpful to me.
Yes.
When I was anxious and everything, you told me how to breathe and how to relax. And
yes, I listen.
You were
to
always.
We are like family.
Yes, it is.
I think we can say that.
Yes.
It's like your family.
Yeah. And I felt like I was actually at the end of the treatment, and I didn't have the team anymore around me. I really missed you all. I felt so alone.
There's something special between patient and nurse.
You know, I think the experience with acute leukemia and related diseases is the main reason that the extreme pessimism with respect to cure achievement has been suppressed and is much better now. But we still have a ways to go.
Children's leukemia is a very special cell type, acute lymphocytic leukemia. That same kind of leukemia occurs in mice, occurs in cats, occurs in cattle, occurs in monkeys, occurs in apes. But it's a virus disease in every one of those animal species. I believe it's a viral disease in humans. We just haven't looked hard enough or with the specific techniques.
You look back at leukemia experience in the 20s and 30s, it was all negative. And we were able to turn that around.
Emil Frey said that he thought the title related to not just the doctors and the patient, but also the wildness of the cancer cell. Medical researchers are like artists when confronted with a blank canvas. They must invent, mix cocktails, create whole new beings. It's a walk on the wild side, and you've all made it possible to come out the other side.
That's a beautiful statement.
Well, I think the world should know about how lucky we are to have people like you who've saved millions of lives.
Tom Frey was...
he had rainbow vision. He could see up and over things that other people just saw straight ahead. And he saw them in Technicolor when other people saw them in black and white. So he had great prophetic integrity in his viewpoints. And he does.
He really does.
Jerry Bodie used to make fun of you by saying Tom Frey tells the same joke so often that we know him by number, and all you have to do is say 33 and everybody laughs.
You've heard that one before.
Good story.
That's number 34.
Yeah. As a matter of fact,